Number 9, boxes. Eric will make a box without a top by cutting out corners of equal size from a 19-inch by 16-inch sheet of cardboard and folding up the sides. How much should Eric cut to find the maximum volume? And what is this maximum volume? So let's just talk real quick about what we're looking at here. So we have a piece of cardboard, and it's 19 by 16, so it's not a perfect square like I have right now. Let's try it more like this. And we'll say that this longer side is 19 inches. This is 16 inches. Right now we just have a flat piece of cardboard, but I want to make it into a box that, say, it can hold paper or hold, I don't know, water or anything like that. So we want to make it where it has volume. So, and that's the word here, volume. If you remember, volume is length times width times height. But right now my cardboard only has area. It's only length times width. So what do? What happens is we come to our box and we're going to cut some corners off here. So if I came over here, what happens is we cut an even square from each of these 4 corners, like that. So and if I wanted to do the same square over and over, I would just hit my buttons, like that, and now I've copied 4 even squares. Now this is what we cut out. So what I would recommend at home, if you were watching this, just to help you understand what's happening, is just take a piece of paper and cut out 4 corners that are roughly the same size. What you'll notice is this piece of paper is no longer 19 inches long by 16 inches, or in your case it might be an 8 by 11.5. It's no longer that length because you cut off these edges. The new rectangle will have a full value going from here to here, and I'm going to have to edit my shape here. This will become the new area from here to here, and you'd have these little flaps here. You'd have 4 flaps standing up that way. And so what do we do with those 4 flaps? Well, we're going to turn this into volume. So we have a new area that's now shorter, or smaller, because this length got shorter and the width got shorter, but we created a height. This becomes a flap that can fold up. Now this, we do not know the length. We just cut out some amount. And so in mathematics, we represent something we don't know by x. Since they're squares, each side length is x, like this. So what can I now say? If I wanted to find the volume, we had length times width times height. Well, I now know my length is no longer 19. It's 19 minus this x amount minus this x amount. So this new length is 19 minus 2x. That is my new length. So I'll do L equals there. Now over here I have my width. It's no longer 16. It's now 16 minus this x and minus this x. So I'll rephrase this as 16 minus 2x. But I've created a height. Do now have a height, which I did not have before. My height is this little flap that's sticking out after you cut off those corners from your piece of paper. It's a height of x. So I can plug this into the calculator, say that v is equal to, and I'm going to substitute anytime with parentheses, anytime I substitute in. So instead of length, I'm going to say 19 minus 2x. And that's going to multiply times 16 minus 2x. And then that will multiply times the height of x. So that's my equation. So let's go type this into graph. So I have 19 minus 2x. We had 16 minus 2x. That was the width. And now for my length, for my height rather, I plug in x. And I get this graph. Now I want you to think through this. If you were cutting at home, you could figure this out real quickly. There's only a certain amount you can cut, because at some point in time, if you're cutting a side length and you're cutting more and more and more off, let me do this one so it's a little bit better, and you've got a match on each side, you're going to find out that pretty quickly run into a problem when you get to cutting halfway, because at some point in time you're going to cut so much off here. When you come off and cut from this direction, you would cut off the entire side. Which, again, if we were trying to find volume, it's once you cut one length, let's just say you were holding water inside this shape right now. If you cut off the whole wall here, all the water would spill out. Now, why do I use that illustration? Over here, this is referring to volume. Remember, volume is in the place of y. Height is x, or the amount we cut. Volume is the y. notice the volume goes to 0 here, here, and here. And that's because at these points, this is the halfway point. This should be 8 units long, because at 8 units long, that's when this was halfway. And if you cut this one halfway and then cut this 8, the wall spills over. Just the same, that other 0 is at half of this value, which would be 9.5. So why do I say all this? The maximum volume will occur between with x, I should say this, x in between two values. And I shouldn't say equal to either, because 0 means I haven't cut at all. So I do have to cut, otherwise I don't have a volume, I only have area. Again, we wouldn't have a height. So I have to cut something. So greater than 0, and it's got to be less than 8, half of the shortest side. So that's where the maximum is going to occur. It's somewhere between those two values. So when I go to my graph over here, I'm going to say analyze graph, and it'll always end up coincidentally, and really it's not coincidentally, but maximum. I'm going to go as far left as not cutting at all, which is 0, which will always be a x-intercept there, to 8, which is again the x-intercept, because that would be like no volume. And it says here, if x is 2.88, I have a y value of 390. So now I'm going to go back to what the actual question says. How much should Eric cut to find the maximum volume? And I'll say the maximum volume, again, volume's in the place of y, is 390. And we were in inches, and so volume is inches times inches times inches, also known as inches cubed. So the maximum volume is 390 inches squared when we cut, or when Eric cuts 2.88 inches from each side. That is not how you spell side. Let's try that again. S-I-D-E. There we go, each side. And this would be our answer. Now, just to prepare you, sometimes when I test this question, I don't always write when's the maximum volume and what's the maximum cut. I might say, what's the length? Well, if you wanted length, you would say, okay, length is right here. And so now that I know what x is, I'll plug in 2.88, say the length equals 19, or here you go, 19 minus 2 times 2.88. If you needed the width, you would say 16 minus 2 times 2.88. If you need to know the area, you could plug those in and multiply them. Or, if you're thinking on your feet here, area would equal length times width, which means area is the same thing as volume divided by h. You could take your volume and divide the x right here, and you would have your area.